Right, then in this section we're going to look at reversible reactions. So what are reversible reactions? Well, a reversible reaction is a chemical reaction that results in an equilibrium mixture of reactants and products. So let's say we have two substances, A and B, and we react them to make C and D. We can then react C and D to get back to substances A and B. So, as the name suggests, we can end up with what we started with by reversing the process. There is a special symbol used to represent reversible reactions, and it looks like one arrow on top of another, facing in a different direction to the one below. Okay, let's do an example. Ammonia is made by reacting nitrogen and hydrogen together in the presence of an iron catalyst, and this is known as the Haber process. Now, nitrogen is obtained from air, as don't forget air consists of mainly nitrogen, and then oxygen plus a small amount of carbon dioxide and other elements. Hydrogen is obtained from natural gas, such as methane. The catalyst in this process is iron, which is thinly coated onto a metal gauze to give it a greater surface area. There has to be the right conditions to manufacture ammonia, such as the temperature of 450 degrees Celsius and a pressure of 200 atmospheres. On cooling, the ammonia liquefies and is collected. The remaining nitrogen and hydrogen are then recycled. The reason why 200 atmospheres is needed is that high pressure favours the reaction that produces fewer molecules of gas. There are 4 molecules of reactant gas, 1 nitrogen and 3 hydrogen, but only 2 molecules of the product. An even higher pressure will produce more ammonia, but achieving very high pressure costs more than the value of the extra ammonia produced. So, a pressure of 200 atmospheres is a compromise between the amount of ammonia and the cost. The reaction that takes place to produce ammonia is known as exothermic. This basically is heat released during the reaction. If the temperature is too low, then the reaction will be too slow also. So what can ammonia be used for? Well, it can be used to make fertilisers, nitric acid, and wait for it, explosives. Nitrogen-containing fertilisers are made by neutralising ammonia with either sulfuric or nitric acid. The following equation shows how this is done. The oxidation of ammonia forms nitric acid. Okay, time for a quick quiz.